So now that we know all of these different derivatives, we're going to use them to find the second derivatives. Notice, kicking it up a notch. The second derivatives for all the following functions. And some of these are going to be easier than others. All right, so let's start off with the first example, which actually I'm going to go even further in the first example and give a few different derivatives. So the first derivative, which is dy over dx, the derivative of cosine is negative sine of x, according to rule number 14 right here. Derivative of cosine is negative sine. Okay, so then the second derivative, which is what they asked us for, is equal to negative derivative of sine, which is cosine of x. And there we have it. Now, just in case you're wondering, this would be y prime, this would be y double prime, if you want to use that notation. Then we have the third derivative. So we'd have d cubed y over dx cubed, which is the derivative of cosine is negative sine. So that'd be negative sine of x. In other words, it'd be sine of x, right? Which would be y triple prime or y to the third derivative. And then just for fun, I know it didn't ask for these, but this particular one's so interesting because it just cycles through. Derivative of sine is cosine again, and we're back to where we started from. So this is the first derivative, second derivative, third derivative, fourth derivative, and then you'd be back to the beginning and you just keep cycling through these four. So negative sine, negative cosine, sine, cosine, right? There are your answers. Now this was the one that was specifically asked for, but it's interesting to see the cyclical pattern of sine and cosine. Okay, now I won't do that for any of the other ones. This was just, for fun. So let's go look at letter B. All right, first thing we want to do is if we want to find the first derivative, we need, or the second derivative, we need the first derivative. So I need to have dy over dx. Okay, well, this is the multiplication rule. I have an f right here, right, or a u if you want to think of it that way, and then a v right next to it, right, or g if you wanted to use f and g. It doesn't make any difference. So f, g. So they're multiplied, so I have to use the product rule. So I'm going to use rule number, let me think, product rule is rule number 7, product rule. So I'm going to take the derivative of f, that would be 1, times the derivative of, or excuse me, not times the derivative. So take the derivative of 1, leave the other one alone. So leave cosine of x alone. So there's f prime, there's g, plus, and now reverse it. Leave x alone, and then take the derivative of cosine, which is negative sine. All right, well then we'll just simplify this just a touch. This would be equal to y prime, or dy dx, is equal to the cosine of x, cosine of x minus, not equals, minus x sine of x. All right, so that's the first derivative. The second derivative, I'm going to have to use the product rule again right here. So I have another x, and then I have a sine of x for that portion of it. And then the cosine is fine. The cosine's on its own. So let me write y double prime would be equal to derivative of cosine is negative sine of x minus, and then for the derivative of this portion, I'm going to need the product rule. So I need f prime, so that would be 1 times g, which would be sine of x, plus, and then now I leave f alone, so it's just x, and then the derivative of sine, which is cosine, right? So I have to do another f prime g plus f g prime, right? Another product rule. So I'm using product rule, which is rule number 7 here, to go from here to here, right? That's product rule, rule number 7. And then I'm doing it again right here to get to this portion. So again, that's rule number 7, product rule. All right, well, I'll just kind of combine like terms and simplify this. So this is negative sine of x minus a sine of x, because 1 times sine is sine, minus x cosine of x, right? Because I distribute that negative to both of those terms. That's negative 2 sine of x minus x cosine of x. That would be the second derivative. Oop, which is what they actually asked for. Except I messed up slightly with my box here. There we go. All right, now let's do it for tangent. The derivative of tangent is secant squared. So dy over dx, no problem. Dy over dx, or y prime, whichever way you want to write it, according to rule number 15 up above, is secant squared of x. Okay, so that's fine and all well and good, but the problem is we don't know how to deal with a function to a power like that. We haven't learned that rule. It's called the chain rule, but we haven't learned it yet. So we're going to have to use a little bit of algebra and realize that secant squared by definition is secant times secant. Hey, that means I'm going to be able to use, you guessed it, product rule, because that's one function times another function. So when I want the second derivative, right, y double prime down here, I'm going to use the product rule. So I'm going to use rule number 7 again, right? So number 7 is going to get me from here down below. So let's think. I need the derivative of secant. Well, the derivative of secant up above, according to that list, is secant of x tangent of x. That's the derivative of secant. Leave the g alone, so then I just write secant of x, right? So there's f prime right here, there's g plus, and then I reverse it. Leave secant alone, so secant, the f, right there, times the derivative of secant again, which is secant of x tangent of x. And if you're thinking, those look familiar, yes, they do. They're like terms. So this is secant squared of x tangent of x plus another secant squared of x tangent of x. So that would make 2 secant squared of x tangent of x. That's your second derivative. And again, if you want to write y double prime, that's fine. Or Leibniz notation, d2y over dx squared. That's also fine. All right, last but not least, the most difficult one. So I have cosine times sine here. So you can tell, obviously, we're going to need product rule because this is f and this is g, or u and v, again, whichever way you want to think of it, it's fine. All right, so y prime would be equal to, and then I'm going to leave, or take the derivative of cosine, which is negative sine of x, then leave the sine alone, so sine of x, that's g, plus, and then I'm going to reverse it, leave the f alone, so I'll write cosine of x, and then the derivative of sine, which is cosine. So let's think. This is my g prime right here. This is my g right there. Oop, I don't even need to write g right there. It's kind of obvious, right? And then this in the beginning part was f prime, right here. That's f prime. And this is f. Okay, so let's simplify that just a little bit. Actually, we don't really need to. Let's just leave it because we're going to take the derivative of this. So I want the second derivative. So I want to use a new product rule on each one of these. Yuck. Okay, so y double prime would be equal to, just consider this first term right here, just that. All right, so that becomes my new function. You can call it u, and then the one behind it you can consider to be v. Right, so here's f prime, here's g. So f prime is my new function. So I'm going to take the derivative of that function. Well, the derivative of negative sine is negative cosine. We actually already proved it right here in letter A. So I want the derivative of that, which is negative cosine of x. Right? That's the derivative of that piece. Then I'm going to leave the sine alone. There we go. So derivative of negative sine is negative cosine. Leave the sine alone. Sine of x plus, this is still working on this term right here. I'm not going any further than this right now. Plus, then leave the negative sine alone. And then derivative of sine is cosine. All right, so all of that is just this first term right here. That gets you this. Then I have a giant plus sign, so I'm going to put a big plus sign in the middle of it. And now I need the derivative of the back piece, which I think I'll do in like blue here. And actually, let me erase this f and put it up above just real quickly. So right here, this little piece right here is going to work down here. So I need to use 2 product rules on this, not just 1. So I needed actually 3 altogether. So I needed 1 application of the product rule to get me from here to here. So that's product rule. And then I need another application of the product rule here to get from this bit to here. And then I need another one from this bit down. So I need 3 product rules total. 1 for the first derivative and 2 more for the second derivative. Okay, so for the second derivative, derivative of cosine is negative sine. Then leave the cosine alone. Plus, and then reverse it. Leave the cosine alone. And then take the derivative of cosine, which is negative sine. So let me think. I'm just looking for a highlighter. This bit right here is the derivative of that portion. And let me think. Just looking for a highlighter here. This portion right here is the derivative of that portion right there. All right, now it looks horrible. However, this is going to simplify down a lot because in case you didn't notice, there's things going on here. So this is negative cosine sine, negative cosine sine. So these two are both like terms. So it's negative sine x cosine x minus sine x cosine x minus another sine x cosine x and minus another one. Every single one of these terms is exactly the same. They all end up being negative sine x cosine x, which means our second derivative, d squared y over dx squared, which is y prime, same thing, is negative 4 sine x cosine x. They all ended up being like terms. And if you're thinking, man, there has got to be an easier way than doing triple applications of the product rule, and the answer is yes, there would be, and it's called, well, there are other things you can do, but you could use some trig identities and you could use the chain rule. So if you know some trig identities and chain rule, you can make this work a little bit easier, but we're not there yet. We'll get there in a later section in this chapter. So for right now, you're stuck using lots of product rule.